This is Self-Directed Research. Our hosts, James and Amos, get hyped about different topics and take turns each week presenting their ideas to each other. You can check out the website, YouTube, or Spotify to watch this episode's presentation, and visit sdr-podcast.com/episodes for presentations, videos, show notes, and transcripts. New episodes are published every Wednesday. This episode is brought to you by Code Crafters. Check out the link in our show notes or listen at the end for more information. And now, in a rare direct follow-up to last week's episode, Amos shares an even more different take with Merde is not Serde.
Exciting. I'm also on Ethernet for this computer.
Nice.
I'm on Wi-Fi. Also, this is like a perfect follow-up to last week's episode. I mean, honestly...
Yes, that's why I did it. That's why I threw away my other decks and made one.
Like, screw everything else. We're doing this.
Yeah.
Perfect.
Did you see that D. Tolnay commented on my post on the approach that Postcard 4th used and was like, yeah, I'm pretty sure that's the optimal way to do that.
Yeah.
That's what we should be doing if it stabilized in the compiler. And I was like, oh. And he linked a post from like a year ago where he's like, yeah, I'm pretty sure you want to turn this into a bytecode format and then just run through that because that's going to end up being optimal. And I was like, oh, okay. Well, one, he beat me to the punch, and two, wow, it's a little reassuring.
Mm-hmm. I did so many cool things with my website. You know the saying about history, like sometimes weeks happen in years and years happen in weeks or something? Well, years happened this week. I don't know. I did a lot of things for my website, and I'm excited to talk about every single aspect of it. But this is not what we're talking about today. Today we're talking about Merde. It's pronounced Merde. Okay, this is a pretty fun joke. The title of today's presentation is Merde is not Serde. The subtitle is Another Take on Deserialization in Rust. And I have been forced against my will to talk about it now, even though it's not perfect yet. It's going to be perfect soon, but it's not yet. Because James did his own take on another Serde, another possible Serde. And so I had to present mine, which is actually in version 8.1.2. I've been doing some major iterating on this thing. And people have asked me a lot, are you aware that merde in French means poop? And yes, I am. This is the logo for the library. It's drawn by Misha. There's going to be a link to her website in the show notes on sdr-podcast/episodes. Where you can find the slides as well. And it's what I want Serde to be, which is very different from what you want Serde to be, James, because I want something that builds fast. I think actually we're aligned on that part. But then I also want a lot of functionality, and I mostly want to deserialize a bunch of JSON because I have a website. So I deserialize a bunch of stuff, and I hate the big code gen. I hate the long compile times. I hate the proc macros. So I did like a quick hack for myself, and then things got out of control, as they tend to do. So now I'm maintaining a whole ecosystem. It does support deserializing JSON, YAML, and message pack, just because that's what I was using on my website. And it does support serializing JSON and not any of the other ones. There's no reason why it doesn't, just I haven't gotten around to it.
I haven't needed it yet. Yeah.
Someone said, hey, can I contribute KDL support? I was like, knock yourself out. I mean, things are still majorly shifting in the crate, as you can tell by the major version number increasing rapidly. But yeah, it is in production in my website. So if you can pawn my server somehow because I forgot about something in Merde, then, more power to you.
I'm getting my denial of service vectors ready.
One big thing that's been bothering me in the Serde ecosystem is that everyone is using the Serde JSON value type. When you deserialize to something, you don't know the shape of it. You're not sure it's kind of the any type of the deserialization word. You use the Serde JSON value, which looks like this. It has null, it has bool, it has number, string, array, and object. And you don't really get to choose much. This is pretty much set in stone. I don't think they can change it at this point. Like adding a variant would be breaking, changing the type of a variant would be breaking. We're pretty much stuck with this. Even for formats that are not JSON, you can take a binary format and deserialize it to that. But then if you deserialize, if there's like a byte slice in there, it's going to be an array of U8.
Yeah, I actually have another crate, postcard din, which transcodes postcard data into JSON. And I actually just use Serde JSON value for this because when you don't know the shape of it, it's an easy, if you have a heap, you can stack items here and it just works. But I guess that's the trappings of success is once it's popular, it becomes very difficult to change.
Yeah, I want to make it very clear that part of the reason why I'm able to experiment with Merde is that Rust has changed and I don't have any compatibility guarantees. I'm sure that they would like to change some things in Serde if he could, but Serde v2 is a hard sell in the Rust community. The v1 is a big selling point. So changing it has to have some significant upsides. And this is not what I'm trying to do. I'm just exploring the space in a very different part of space than you were, James. So that's why it was funny to me. One thing that I noticed in that enum is that object has a map type, and I was like, why not just use hash map? Clearly they're using the base type. The string is just an own string in Rust. Number, I don't know what number is hiding, but the thing that is hidden behind map is whether insertion order is preserved or not. So it's an alias, or like it's a struct with a hidden impl in there that forwards all the implementations to the underlying thing, and it's either a B-tree map, which is ordered but not by insertion order, or it's an index map, which is like a regular map, but it also keeps the insertion order, and so it iterates by the order by which objects were inserted into it. Yeah, I'm sure you know what I mean.
Yeah, I do think B-tree map preserves insertion order.
No, it doesn't. It orders keys, so keys must be comparable. Like they must implement ord, and then when you iterate, it iterates from smallest to largest. But it doesn't preserve insertion order. That's why I was confused. I was like, oh, B-tree map if it's ordered. No, wait, no.
Okay.
You can look it up now. We have time.
I'll trust you. I definitely know what you mean with index map because we also have that on embedded.
Because if B-tree map preserved insertion order, why would you need index map, right?
But I thought that's why I use B-tree map instead of hash map in a lot of places. But maybe it's just a consistent iteration order. Well, yeah, okay. I'm going to look it up because we're talking about it.
We are going to look it up. Yeah, that does make sense.
Tap, 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 tap.
Mm-hmm.
Actually, we should go to the top of Stud collections because they talk about this. Use B-tree map when you want a map sorted by its keys. So yeah, I guess you're right. It has a consistent iteration order, but it's going to be sorted by its keys and not in the insertion order.
Okay, yeah, I was confused too because I remember looking at the code base for cargo dist a lot, and it has type aliases for like ordered map versus unordered map. It's good for comparing things.
Yeah.
Because it's going to have a predictable order, as opposed to hash map, which could resize in the middle, or like the different random seed that turn to avoid denial of service. In typical SDR fashion, I have 32 slides and we're spending 10 minutes on slide 4. So anyway, it's just using basic Rust types, but it's Serde JSON. People kind of standardize on that. You can serialize to a Serde JSON value. You can deserialize from a Serde JSON value instead of like some input in some markup format. I decided to make the value type a first-class citizen in Merde and add things like bytes and add things like copy on write. You can see cow stir, you can see cow bytes, and different array and map types. You can see I64 and U64 because, well, U64 can have larger values than I64, so not everything fits in there. You can see float is an ordered float, so the whole type is ordered. That's a compromise. But basically, F64 does not implement ord because you're not supposed to be able to order nans, I think.
Yeah, exactly.
Nan is smaller than nan is always false, but nan is bigger than nan is always false as well. And there's like 4 million nans. It's a lot of nans.
In F64, probably, yeah.
Yeah. A big thing I wanted to do, because I was like, I'm going to compromise on a bunch of things. I'm going to compromise on monomorphization because I want better build speeds. I'm going to compromise on, I don't know, doing dynamic dispatch, which is the same kind of compromise. One thing we can have for free is just borrow from the input instead of copying to the heap whenever we can. So we have the cowster and cow bytes types. Every Rust project has their versions of cowster because there's a cow type in the standard library and you can pass it a reference type.
Stir.
Like stir, and then if that type implements to owned, then you have your pair of types. You have the borrowed type and the owned type, and in this case, the borrowed type would be stir slice, so ampersand str, and then the owned type would be the standard library type string with a capital S, which is the own version of a string. But I don't want string to be the own type. I want compact string to be the own type because if you have a lot of short strings, it's kind of silly to do a tiny allocation on the heap and put like 8 bytes there if you have a lot of first names or something.
Yeah.
In the space that it would take to point somewhere in the heap, you can just store the data inline directly. There's a slew of small string crates.
Yeah, I was going to say, which one are you using? Because I know there's like 8 and they all go back and forth on which one is...
I'm using the best one, obviously.
Oh, clearly.
Which is compact_str.
Okay.
There's going to be, again, links in the show notes. And the same thing for bytes. You can do the same trick for bytes. You just need a different crate. It's a crate that was actually based on compact_str. I did a review of all the small string crates a few years ago, and it's out of date. And now the best one is compact_str. So I should update it.
Pro tip.
As I mentioned, a priority for Merde is build speed, because I like to iterate on my website a lot. I interact with a lot of APIs. I interact with the Reddit API, the Patreon API, the GitHub sponsors API, my own APIs internally. And so I don't want to be spending my whole time compiling Serde generated code, which we've already brought up a lot in this podcast. We know that it's an issue. One of the things that make compiling projects with a lot of Serde derived types, it's Serde derived, just to be clear, it's not Serde itself, it's Serde derived specifically, which I think most people are using. I think very few people are doing manual implementation of Serde's serialize and deserialize type if they can help it.
And even if you aren't using it personally, if you have dependencies on types that have a Serde feature, you're still going to be pulling it in your dependencies and paying that cost, really.
Yes. And proc macros are really hard to cache properly. There have been some experiments to enable caching for proc macro output. If all the inputs are the same, then there's no point in even compiling the proc macro code and running it. It's a long story. We could have a whole episode on that, but there's gains, but it's hard to determine what the actual inputs of the proc macros are. It could be arbitrary code. And even if you sandbox all the things, you still have to compute cache keys and all that. And at the end of the day, it's really hard to come up with a solution that works for everyone and actually speeds up build rather than slowing them down. Caching is hard.
Yeah, especially when you have non-sandboxed items, and the fact that proc macros can be side effectful and are allowed to do things like write or read from disk or make network connections like Diesel does.
But I have used my superpower. I have complained online about it, which let me know that people were already discussing what can we do. And constraining what proc macros can do, giving them a way to make up their own cache key, and then if they get it wrong, it's their fault. There's a lot of things to do. Again, different episode idea for later. But in Merde, no proc macros, only declarative macros. So this is what Serde would look like. You use the serialize and deserialize trait and derive macros. Both symbols are named the same. Rust namespacing rules are fun. And then you have this attribute on top of your struct. So if you have a struct points with two fields x and y of type i32, on top of that, you just slap pound, hash, octothorpe, whatever, the little sharp symbol, and then square brackets, derive, serialize, deserialize, debug. So nice thing about that, you can derive Serde's traits the same way you can derive debug, which is a built-in derive macro. But in Merde, you don't do that because that would be slow. So instead, you just have a normal declarative macro. So first you declare your struct, just as usual, derive debug, struct point, two fields x and y of type i32, and then separately, you call Merde : derive, or you can import derive into your namespace. And then in there, you have this kind of weird DSL, a domain-specific language, and you say which traits of Serde you want to implement. Maybe you only need to deserialize. You don't need serialize. Just like with Serde, you can implement one or the other. So impl, what looks like a tuple, but it's just a list of traits. So impl, open parentheses, deserialize, comma, serialize, close parentheses, and then for struct point, and then a list of fields. So struct point, pointy brackets, x, y. You just have to list the fields again. Because it's a declarative macro and not a proc macro, it doesn't see the body of the struct declaration, so you have to list the fields. I'm very happy that you don't have to also repeat the field types, but you do have to give it the field names.
I'm very interested to what happens if these fall out of sync, and I'm sure there are errors that go on.
It's actually not that bad. A thing that's great about declarative macros is, sure, it's not dry. Don't repeat yourself, DRY in the acronym, but the error reporting is actually pretty solid. Rustanalyzer is able to see through the invocation and everything. It's not as awkward to use as I thought it might be. And if those get out of sync, you do get errors. If you specify a field that doesn't exist, it's going to be like, well, point doesn't have a field called blah. And if it's missing one, it's going to be missing field. Like when you do a struct literal and you're missing a field, it's just going to say you're missing field. It's actually not that bad in practice. I just don't like that you need to repeat yourself. So that's why I was thinking about something more like code gen. That's actually my last slide. But I was thinking about code generation because now that I have those declarative macros, I could just have like a separate schema files that would generate both the struct definition and also the macro invocation, or even just the trait implementations.
Yeah, I've looked at that for Postcard as well. I think that's sort of the ultimate aim, or not ultimate aim, but like it's the last step you have to hit. And it's one of those things where you end up with something like Proto-C from Protobus, where you just have a schema file and you just do code gen from them. And either for flexibility reasons or for one of the things for Postcard is to be able to support other languages, because Serde is very nice, but it's very Rust, which means if you want to generate decoding and encoding libraries for another language, the proc macro is probably not going to help you very specifically.
Yeah, there's a crate called Schema RS, which supports the same annotation that Serde does, and you can generate JSON schema definition files so that you get autocomplete in editors and whatnot. And that's great, but it's all a hack. It's all like Serde was the first big thing that took off. It happened after Rust Serialize, which now you can see some traces of that. Like, don't use that. That was early on. We deprecated it. We removed it from the standard library. Don't look at it. But yeah, Serde is the standard. Everyone's adopted it. I think you don't see a lot of experimentation outside of that. There's like only the zero copy frameworks because they really don't have a choice. The zero copy serialization and deserialization cannot just use Serde traits. But apart from that, everyone else is just like kind of stuck with the Serde interface, which is a blessing and a curse. So back to Merde. This, again, you should be looking at slides. I'm sorry, this is going to be a slides heavy one. Go to sdr-podcast.com/episodes to look at the slides. You can derive, deserialize, and serialize for structs that are fully owned. So the struct doesn't have a lifetime parameter. But even if you do, that's kind of the thing. Copy on write all the things. If you have some cow stir fields, if you have regular cow stir lifetime fields, if you have whatever things might borrow from the input, there's only one lifetime allowed, as opposed to Serde, which has more flexibility. You can have different lifetime and specify which one's actually borrowing from the input. Here, you can only have 0 or 1. And if you have 1, then in the invocation of the derive macro, you just add the lifetime parameter. So it's struct name, angle brackets, single quote s, and then the list of fields.
Do you support generics too? If that's the next slide, just go to the next slide. But I run into this with Postcard RPC has a macro where I wanted to accept lifetimes for borrowed types. It's not so far from this, but trying to support both lifetimes and generics between the angle brackets in a macro by example is challenging because I couldn't figure out how to get them separate, because for what I was doing specifically, I needed to have the lifetime separate. I couldn't just have a token tree of all of the characters, because when I use them in different positions, I need to put the generics in one place and I need to put the lifetimes in another. So I'm wondering if you've solved that or if you just said, not my problem yet.
I have not.
Oh, okay.
No.
Yeah.
I don't have any generic types. Like I said, it's in production on my website because I was tired of waiting for things to build. Yeah. So I moved everything to Merde. And a lot of the iterations are like me running into the next step of, oh, for this scenario, it doesn't work, so I need to change the design. But no, I haven't done generic type parameters yet. Only lifetime parameters, and only one of them. So what do? You want to turn that into name static. And how do you do that? Usually, I don't know what people do. They just do toOwned. They implement toOwned manually. Well, you can derive, kind of. It's not really a derive macro, but it implements IntoStatic for you, which has a type parameter called output, which is constrained to have the static lifetime. And it's a very weird trait because output is supposed to be the same as self, but static. This is the first Merde presentation on this podcast, and maybe not the last, because there's a whole bunch there's a with lifetime trait so that I can define a deserialize owned trait and like map from any lifetime to that type, but with the static lifetime. I didn't figure it out. Someone figured it out for me on social media. I asked the question, hey, is that even possible in Rust? And I got 80% questions like, why are you trying to do that? Why don't you know Rust? Clearly, you should know that it's not possible in Rust. And then there's like some person from somewhere, they've been following me forever, and they're like, I think I found something. And you're like, oh, wow, that's dirty, but it works. This is a teaser for a future episode.
Have you ever seen Manisha's 3-part blog post series on zero copy, yoke, and I forget what the third one is, but
I have an open issue for yoke support because it's fun. Yeah.
Yeah, I was gonna say it's the exact same thing where you're trying to support copy on write types, or really instead of just taking the slice from a cow input, kind of taking the cows or doing a clone of the cow and things like that. It's a tricky lifetime problem because all of this is geared towards like what the input is, but if the input's a borrow of the cow, sub lifetimes and stuff like that.
Okay, yoke is super interesting because it's a middle ground between we're borrowing from an input, and so we can only exist as long as the input exists, and you can only call deeper. You can call to a lot of subfunctions, but you can never return anything tied to that input, or it's complicated. Or you copy everything to the heap on compact type, like compact string. And yoke is like, no, if you move the source along with everything that borrows from it, then that's fine. But the Rust type system doesn't really let you encode that. So we need to use a bunch of unsafe code and like expose a crate that lets you do crimes, but in a sort of controlled environment. It's like Rubicon. It's a really
bounded crimes. Yeah.
I want to bring yoke support into Merde, but it's not done yet. The hazard here, I guess, is imagine deserializing a 2 GB document and you're borrowing a tiny string from it. Yeah, you're lugging around the entire source document. JavaScript has the same problem. In browsers, strings are transparently borrows or copies of things, and sometimes they can retain, like act as garbage collector roots for very large data sets. And That's what memory usage is caused by sometimes.
Yeah, the bytes crate in Tokyo as well has this problem where it tries to do that kind of like copy on write sort of behavior. But if you have a whole 1 megabyte buffer and you're borrowing 3 characters from it, surprise, you get to keep the whole buffer alive for as long as that little borrow is alive for.
And that's really hard to find out because when you're designing, when you're writing the code, you don't know what the input's going to look like necessarily. So it could be that the design was sound, but then later on the shape of the input changed and now suddenly it's using a lot of memory. So it's a good reminder that our instincts are usually wrong, and it's better to just go and measure things with the right tooling. Just like Serde, Merde has a deserialize trait. It looks a little bit funny, but James, don't say anything. It takes a lifetime parameter called S for source. It is sized for unclear reasons, I forget why. It takes a mutable reference to a deserializer because what the deserializer does is simply yield a bunch of events. So that's a big difference from Serde. Serde has methods per data types in the visitor interface or something, in the deserializer interface. I don't know. It has one method per type, which is great because it's static dispatch. The compiler knows exactly the path of the code it's going to take. You can inline everything. It's very, very fast. I just like enums for some reason. So we have a big event enum that has one lifetime parameter. It kind of mirrors the value enum, but it also has map start and map end, array start and array end. Some formats are self-descriptive, and so you get a hint as to the size, the number of elements in the map or the number of elements in the array, and that's your queue. Some are also self-descriptive. I was thinking with JSON is technically self-descriptive, but you don't know how long an array is going to be. You just know when it starts and when it ends, and you have the difference between I64, U64, F64. I haven't shown an implementation of Deserialize, but basically, yeah, you ask for the next event and you look at what it is. And if it's not what you expected, then you return. Which another thing that's not really covered in the slides is what do you do if you get the next event and it turns out you shouldn't have? There's no such thing as peak. There's only next. So you can't put back an event in there. But then what happens instead is that there's a deserialize starting with, and you can pass the first event. So you can kind of inject an event back into the stream, which is needed in some scenarios. It's kind of dirty. I don't really like it, but it works.
If you're taking a stream of events, how do you handle out of order struct fields? So if struct says that it's A, B, and C, but because JavaScript or JSON or whatever has reordered the fields, they might send CAB on the wire. Does that still work within the map start? Is it just like collecting all of the items and you go, that's still in the list, it's fine?
Basically what it does is it just asks for events and then you look at the key names and it has in scope a bunch of bindings that are option the type of the field. And that's an interesting part that I didn't really show up, but there's a way to, without knowing the type of a field, if you just have the struct name and the field name, you can declare a local of type option the type of the field. And that's what the declarative macro relies on. So you just have a bunch of fields and you just assign them. And then at the end, if they're none, then you're like, I guess we missed that field. And you also know if there's duplicate fields, you can decide what to do about that. There's a bunch of things you can do. This brings us to our next slide, which is how do you specify without the flexibility of field level annotations like you have in Serde, how do you specify if you should, deny unknown fields, but that's container level annotation, or whether you should allow, just fall back to a default value for some field if it's absent or something like that.
You've made up a crate on the internet just so it can have opinions.
I truly did. There's a DeserOpinions trait that has a default implementation in Merde. And I gave the trait definition here. It has a deny unknown fields function, which returns a Boolean, pretty straightforward one. There's a map key name function. It gives you the name of the key for a map, and then you can either return it itself because it takes a counter and returns a counter, so you don't need to copy anything. Or you can map it to something else. And I have a real example here. On my website, I tend to deploy before an article is ready, so it's in draft mode, and sometimes I want to get others to proofread it, and so it has a draft code in the front matter, the YAML front matter at the beginning of the markdown, and it used to be called, the Rust field is called draft underscore code in snake case, but in markdown, I want to write it in kebab case, so it's draft dash code. The third method currently in DeserOpinions is default field value. That one made people angry on the internet because it takes a key. This time it's borrowed, you can't mess with it. It happens after map key name. So first you get to translate the key name to something else. And this is less efficient than Serde. It's also more flexible in a way. you could look up that key name somewhere if you wanted to. You could have a generic change all snake case things to kebab case things or to camel case things. So it's a compromise. Something costs at runtime, but it's less code also in the binary. Honestly, in the context of web application servers, it's totally fine, unless you're Amazon. But I'm not, so I'm fine. And then the default field value takes the key as a borrowed string, and then it takes a slot. And that's awkward because, again, we're not in the Serde universe where we can generate things precisely based on the type of the fields. Here, that single function has to work for every field of any type. So the field slot type cannot be generic over the type of the field, which brings us to a problem. What happens if you pass like the address of an option I64 and someone tries to put a string there?
What does happen?
What does happen? Well, what happens is I have a vendored version of mini type ID, and it just says it's not the right type, but it's not very safe.
Okay.
But basically in Rust, there's a type ID function in the standard library. You can pass it any type. Well, as a type parameter, there's also type ID of, I forget the exact name of the function, but yeah, there's a type ID type. You can get some value that is unique to that type, and you can compare those so you can tell if two things are the same type or not. But that doesn't work if you have lifetimes, which we do because we borrow things. Yeah. So that's why you need a separate thing. And that's why it doesn't use the standard library one. It's a thing I stole from somewhere, but it's in the comments where I stole it from. So I think it's okay, license-wise. I don't know. Don't sue me. Just ChatGPT that shit, bro.
Uh-oh. Hate that.
Oh, and then how do you use opinions in the derived like DSL for Merde after impl, deserialize, force struct, blah, with the list of fields, you can do via, and then the name or the opinion, the type that implements the opinions. So I thought that was interesting. All of that could be done via a more complicated DSL inside the declarative macro, but the declarative macros in Merde are already pretty bad. They're already at the limit of what I can read. I got LLMs to generate bits of it, and I had to step back like, wait, I'm not sure what happens here. There's several level of expansions. There's a lot of different syntax variants. I figured out how to simplify them in the last release, but it's really kind of pushing the boundaries of what you should be doing with declarative macros, which is why I was excited to see you also doing declarative macro crimes, James, with the whole generating schemas at compile time and like mixing const and declarative macros. That was fun.
I don't think I picked up on this originally, but I think you mentioned it. So you have your own deserialize and serialize traits. These aren't using the Serde serialized traits.
That's correct.
You have your own version of it.
That's correct. Merde has its own serialized and deserialized traits for a very good reason. We'll get to that. So let's actually look at the serialize trait. The serialize trait is kind of boring. It takes a reference to self, and it takes a mutable reference to a serializer, and it returns a result. The result is the happy path is the empty tuple, and the error path is the error from the serializer. Pretty boring. Again, there's only one thing that's kind of weird. It's async. It's an async FN in trait, which is something we've gotten since Rust 175. I know because I'm working on a draft of an article that I started months ago and I'm now updating for release.
Yeah, hell yeah.
This is the serializer trait. Just like in Serde, there's serialize and serializer. One other difference. A serializer has an error associated type so that each serializer can have different types of errors. And then the important function, I guess, there's a bunch of other ones that I've hidden from you, but the important one is write, and it takes a mutable reference to self and an event. So events are used both for deserializing and for serializing, which means you can pipe a deserializer straight into a serializer and it should work. Now we're getting to the interesting part, which is why is that function async? And the answer is, well, sometimes.
Oh no, that's not the reason I was expecting. That was not what I was hoping for.
Okay, so sometimes you deserialize deeply nested data structures, like this one. This is example code that generates 100,000 nested JSON arrays. So it's an array that contains an array that contains an array that contains an array that contains blah, 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 100,000 layers, an empty array. And if you deserialize that to a Serde JSON value, you can upload the stack. Because it's a function that calls a function that calls a function. It's recursive, so it's piling up those stack frames, and the stack is a space reserved for return addresses, arguments, some locals, and eventually you're going to run out of space because every thread has some fixed amount dedicated to the stack, which can range from, I don't know, on desktops, maybe 1 megabytes to 8 megabytes or something.
Yeah, it's a couple megabytes.
If you have a lot of threads and you know you're not going to go over, you can make threads with less, you can make threads with more. Okay, so why is this a big problem? Not just a small problem. It's a big problem because if you're accepting user input, people can send you that weird payload, which is just 100,000 nested arrays. And if they can do that and crash your application, then that's a problem for you. So you have to do either of two things. You have to stop them and decide, okay, I'm not deserializing that. Clearly, this is a bomb. This is like a zip bomb. This is malicious. I don't want to run out of memory, so I'm just rejecting that. Or you deserialize it properly without actually blowing the stack.
So you also mentioned that you support deserializing YAML, I believe, or just serializing?
Just deserializing.
Because YAML has the other fun thing where it has referential support. So you can reference other things, which I think is also a pretty big denial of service vector.
I have not tried that.
Oh, okay, cool.
I'm using like an event-based YAML parser and then just kind of translating it to Merde types. I have not tried that. That's a good point.
Because those are the two attacks. Yeah, you get the super nested Stack Overflow, and then you get like the zip bomb where you reference something that references 10 other things, which references 10 other things, which reference, and in some parsers just explodes.
So Merde doesn't actually solve that because it solves one half of the problem. I used to call it infinite stack, but that's not really true. So I'm calling it metastack now. The prior art for this is Stacker. So Stacker is a crate. You can inject calls to it at several points in your program where you think you might run out of stack. And what it's going to do is check how much stack you're using. And if you're using too much, it just grows the stack. And by just, this is a load-bearing just. I should really have looked into that before today's presentation. But what I assume it does is it allocates an entirely different stack, copies everything to it, and then changes the stack pointer, essentially. But now that I'm saying it, it cannot work that way because there's things pointing to the stack. So I'm not sure. Maybe it just chains stack, like it allocates another chunk of the stack and moves there and changes the stack pointer. But then when you return, it restores the old stack pointer. That must be how it works, right? There's no other way.
This is one of those cursed things where I'm used to the embedded level of cursed where you can't extend the stack.
Yeah.
The stack is statically known, and when you run out, you're out.
You barely even have a heap allocator. Yeah.
So it's one of those things where I know how it works on like a very cursed bare metal kernel or operating system level,
right,
but no idea how user space handles this kind of thing or chaining stacks or resizing the stack and stuff like that.
I don't know. Stacker worries me because now that I think about it, it cannot move things that are already on the stack. I'm pretty sure, because that would invalidate a bunch of pointers. In C#, you can do things like that. It has a moving, compacting garbage collector. It's aware of all the things that point anywhere. And so it's able to update pointers or actually references when it moves objects in memory. But there's no such thing in the C, C++, Rust cinematic universe. If something is there, it's not going to move. That's the whole reason we have pin and friends, another complicated topic in Rust. So I'm pretty sure this is how it works. It's like, okay, this stack is full, we'll get another, and then just stack things onto there. And this is kind of what I do in Merde, except instead of changing the stack pointer and things, which is scary, it's terrifying, because what if some other language unwinds? I don't know how that works. Maybe it works well, because you have return address in the stack. I don't know. I'm not sure. Now I'm interested. But basically, instead of doing all that, you can just have an async function, which is a state machine. And what you get to do with an async function is return all the way back to the runtime. You've been stacking these calls to async functions, and you get to yield. You get the return pull pending, which doesn't mean you're done, but it just means you're waiting for something. And in this case, you're waiting for more stack, which is never going to happen. It's not like if you go all the way back to the runtime. I mean, I guess it could. What I did instead is that when you're about to run out of stack, it creates a next future, it stores that in a global, and then it yields all the way to the runtime, and then the runtime is like, oh, it wasn't ready. I pulled the Deserialize function, the feature, and it didn't return poll ready, it returned poll pending. Let me check the global. Sure, okay, there's more work to be done. Let's do that again. Let's do that next work on the stack we already have. And so on and so forth. If that one returns poll pending, it's pushed onto a queue, and then we'll run the next feature, and so on and so forth, until we're done deserializing, and then we pop from the queue, and then we resolve back. You should see my hands go around, which are not going to be in the edit.
So you're heap allocating new futures, because essentially futures are just an enum of all the state of essentially each of the await points at that. So what you're doing is you're creating a whole new future, and then sort of like daisy chaining all the futures together to get it there. Okay, that's interesting.
The weird part is that initially none of this is async. We're not actually doing async IO at this point. We're just trying to deserialize something synchronously. So on the outside, everything is synchronous. The public API for all this is synchronous. You don't have Tokyo going on. You have nothing. So in there at some point, in the internals of Merde, it sets up a dummy waker that doesn't actually allow registering for being woken up. It doesn't actually have timers. It's not an actual reactor. It's entirely made up. The only purpose is so that we have something to pass to the poll function. That's part of the future trait in the standard library. So that we can, call all that. And if it returns pending, we know that we needed more stack. And we just run the next future and so on and so forth.
Interesting. So it's sort of like the gen await thing where you're really wanting generators. You're wanting like pausable iteration, but you're wrapping the stable interface, which is async, to sort of get something generator-ish out of it.
Yeah. And that's also why the deserialize trait is taking a mutable reference to a deserializer and not like taking ownership of it, because you're lending it to the next future. And then when it finishes, it completes, it's going back to the previous future. It really needs to be able to do that. Like you said, daisy chaining, I think is a good term for that. The result is that you can actually deserialize something like 100,000 nested arrays to the Merde value type, the dynamic. We don't know what it is. So some of it's going to have to be heap allocated, because you can now have infinitely recursive types that would be infinitely large. So if you look at the value enum, you can map an array, they are heap allocated because you can't do otherwise. How do we explain that to someone who's never thought about infinitely recursive types? Like a type that contains itself is infinitely large.
How do you explain it? When you have that level of indirection, like you can have a vec that contains vex, that contains vex, that contains vex. You run into this where the compiler will actually warn you if it realizes this has happened, and it'll tell you you need some level of indirections either through references or boxing or things like that.
I guess imagine an enum with like two variants. One of them doesn't have any data associated to it, and the other one has itself. Then the size of the entire thing is either, it has to be at least 1 byte, because you need to have the discriminant between one variant and the other. And then it also has to have the size of the largest of the variants, which is itself. So it's itself plus 1 byte, plus 1 byte, plus 1 byte, plus 1 byte, because it keeps going. If you keep computing the size, it just recurs and that you get an infinitely sized type. So that doesn't work. But in this case, it does work because it goes through the heap. So you can recurse as long as you have memory, which is why I renamed it from infinite stack to metastack, because you don't actually have infinite memory. However, James, can you foresee any problems with this?
You're not running out of stack, but if you're putting an infinite number of things on the heap, eventually you'll have heap exhaustion.
That is an issue. Yes, that's a problem with current Merde. This is more dangerous than Serde, actually, because running out of stack on a desktop OS is fine. You think it's just going to restart, but running out of memory, it's going to make the whole machine start swapping and become very slow. Like,
depends on how you set your ops on things like that.
Yeah. You better set your quotas right, because
what your memory limit is. If you do force the whole system into swap because it's unbounded, then you'll start swapping into whatever your cheap host is.
But there's another issue with that. I'm really curious if you can guess what the next slide is, because you can't see the presenter view. I see what the next slide is, but you can't. Can you guess? So you deserialize, you build that value that's like very, very deeply nested. And then at some point, you don't need that value anymore.
Oh, does drop become incredibly...
Yes, you just made a drop bomb.
Yeah.
Because drop is synchronous. So you drop the outer array, which drops the array inside of it, which drops the array inside of it. And all those drop calls pile up on the stack and eventually blow up the stack. So you made a top you can never drop. You made a drop bomb.
Oh, interesting. Yeah, I do think I've seen this in the Serde JSON code before.
Other people have made drop bombs before. You have bomb disposal code. You can like go deep in there and start dropping things manually, shift things around so that the stack never gets as deep. Or I guess in my case, I would just make another trait to dispose of them safely, like use the same metastack, async function things, so that you could write natural code. So the whole point is it's weird machinery with a fake runtime and everything, but then you just get to write natural code. You just get to write async function, and you get to recurse as much as you want. You don't need to think about any of it. All deserializer can be protected against too much memory usage because you can measure how much memory you use. It has to go through this weird runtime thing, which decides if you get more stack or not. So actually, I haven't implemented the protection, but there's a single point to do it. Whereas in the Serde ecosystem, Serde JSON specifically has protections against that, I think. But all the other deserializer would have to do their own thing. There's no standard mechanism for that because it's not baked into the deserializer or deserialize interfaces. I have the upper hand because I have zero compatibility guarantees. I get to use modern Rust. I get to break things whenever I want. Some people have started porting things to Merde v3, and I'm like, sorry, it's v8 now. Like, you're 5 breaking changes behind. So don't use it, but do come with me and experiment. You know, the other thing, it's that now that you have those functions as async, you can actually do async I/O.
Yeah, that's where I was hoping you were going with this, because that is a very useful thing.
Because if you're going to change everything, you're going to change all the traits. You're not going to completely go off course of the Serde ecosystem, and everything's async anyway. Initially, I assumed you would read everything and your source is always like a byte slice.
Yeah.
But actually, you can have a reader. You can have a network socket. You can have any type of I/O underneath it. And you can call all the Merde methods synchronously with that fake runtime thing, or asynchronously. And initially, I was confused of how it was going to work, because there's real async where you have Tokyo and you have weird fake async just for the stack thing. But actually, it's really easy. If the next future global is set to something, you need more stack. If not, you're going back to Tokyo. So you're passing through and saying like, okay, is it just a stack thing, or is it actually waiting for a read or a timer or something? So it does work. You can do streaming deserialization from like an HTTP response coming in, and streaming deserialization. You don't need to keep everything in memory.
So you said global a couple times, and that makes me nervous, because what if you're decoding on 8 threads and you have that? Is it a real global?
No, it's a thread local. But now that I'm thinking that it's real async.
Yeah. If it's real async, you're going to be moving around different worker threads, and you could technically have 2 threads. Like if you yield waiting for more data, you could end up...
No, it's fine. It's fine. I just thought about it. You're right. Okay, first of all, it's a thread local. So as long as things were actually synchronous from the outside, it was fine. But now that we're actually doing async IO, is it still fine? And the answer is yes, because whenever you yield, you pass through our fake runtime.
Wait, but do you use the fake runtime for real async, or do you only use the fake runtime when you use the blocking code?
Yeah, because it's the thing that calls poll. It calls poll, and then whenever anything downstream of that, whenever they return poll pending, we see it. So we intercept it.
The interception's not in the executor, it's in the future.
Yes.
Like your manual future impl that wraps the thing. When the actual child future returns pending.
Yes, exactly.
The parent future. Okay, that's what I missed, is that it's the future catching that and not the runtime or something.
Yes. Outside of the deserialization, Tokyo would never get to observe that thread local being anything other than none, because it's synchronously being checked and then immediately starting work on a separate future. But that all happens synchronously. It never yields in the middle of deserialization, which might be an issue actually. But
fun.
I guess it would, because Tokyo has a budget thing. But yeah, I think the thread local thing is sound.
The thread will yield, but the task won't. You can't force a task to yield.
I mean, you just return poll pending. Yeah, well...
You can't force it. Yeah, it has to be... It's cooperative.
It's not preemptive. Yeah, it's cooperative. Exactly. Okay, we're also almost out of slides. One last thing, except for CodeGen, that I'm excited about is that currently the Deserialize implementation has a Deserialize function that is generic over the type of the deserializer. But it shouldn't need to, because it's only taking a mutable reference. So we don't need to know the size of the deserializer. We're taking a reference to a trait. So there's 2 ways to do that in Rust. You either do &mut and then some generic type, or impl trait, or you take a mutable reference to a trait object. But that wording I just learned today, this morning, has been renamed. We used to say that a trait is either object safe or not object safe, but they renamed that to DIN compatibility, which actually means what it says, is like, can you make a DIN out of it? And in this case, because we have an async function in the trait, which is something you can do starting from Rust 175, it is not currently DIN compatible. But there is a crate called dynosaur with a Y, dynosaur.
I was really wondering whether you were going to say dinosaur or dinosaur.
Obviously dinosaur. But yeah, I say din, but yeah, okay. Do you say dine? Like dine compatibility?
No. I would say din trait, yeah.
It's the dinning philosopher problem. So what I want the trait to look like is to actually take a reference of a din deserialize, but I can't because that's an async function in trait, but I could if I use dinosaur. So this is why I was forced to give this presentation now, which is good because it's already long. But this is my next step. One of the big problems with Serde is that you derive, serialize, and deserialize, and then they get instantiated when you actually compile the thing. So if you have a library with a lot of types, the things that gets cached is kind of just the templates. And then when you actually use them in your application, everything gets instantiated and it takes a long time to build everything. What I want is a single implementation of deserialize and serialize, a single copy of the code that works with any deserializer. I want a full use dynamic dispatch, Because we don't care, because it's the application server anyway. We're parsing JSON, for crying out loud. We would use another format if we cared about performance, but we don't. Dynamic dispatch is fine. Heap allocations are fine. We want rapid iteration. We want to be able to deploy a change in a few seconds, like rebuild the entire website. So I want to actually use dynamic dispatch, and that's something that Dynosaur is playing with for now. It's kind of like the async trait crate. It's like allowing you to do what the language will eventually permit you to do, and you can experiment with the design. Just the fact that you're able to use async if an trait. Again, it's a Rust 175, which came out a few months ago. I don't remember when exactly. There's a 6-week release train.
What are we on, 84 or something now? So it's like 10, 60 weeks or something?
183 just released this morning when recording, yeah.
Oh, 183. Okay. So
yeah,
just about a year then.
As I've been adding features to Merde, this is where I confess. Initially, when it was very simple, of course it was faster than Serde. With Serde, if you want types to conditionally support Serde, you have to do CFG attributes. It's kind of annoying to do. Whereas with Merde derive, if you don't enable the flags, the macro just expands to nothing. So you can have it on all the time, which is great. It's very convenient. But yeah, over time, as I added Deserialize and Serialize impls for a lot of traits, like all tuples up to size 20, it's a bunch of code and, rusty turns. So I would like to have this dynamic dispatch thing and see if it fixes anything. I also thought about if I did all of this for nothing and you can just like instantiate types in crates so that they're cached and reused. And I don't know if I told you about this idea, James.
You had the aha moment when I was talking about Postcard 4th. You went, you could do, never mind, we'll talk about that later.
Yeah, it's about instantiating those types. Like I said, you have those generic types in the crates, so they don't really get compiled. They're ready for being monomorphized later. But if you force the crate to monomorphize them by like having a JSON feature, then anything that depends on that could just use those, but that's depending on the compiler flag. More research is needed. That's going to be in another episode. Thanks for coming to my show. You can use Merde right now, but you really shouldn't. Now, I know it's version 8, but even I feel funny about it. It's usable. It's just less flexible than Serde, and it's questionable whether it actually builds faster, but I've had a lot of fun with it, and I'm looking forward to like adding stuff like yoke support, doing actual dynamic dispatch, maybe doing code gen. It's aggravating to have to relist all the fields. I got LLMs to generate that for me, but still, I don't know. I don't like it.
That's good to prototype. It's good to mess around because you want to be able to figure out what is and isn't good before you really commit. It's the opposite of, well, you're testing in production, but it's testing in a more scoped production, which means you get actual feedback from it and you get runtime data and you can see if like you have asserts on and they hit and things like that.
Another thing I put the emphasis on when I was designing this is to get good diagnostics. When deserialization fails, unless you opt into like some other crates, you get very little information. It's like missing field. That's it. Somewhere deep in your document that you don't know where. So with Merde JSON implementation, it has this nice syntax highlighting thing, and it points exactly to the path. It costs memory to keep track of those things, but to me, it's worth it because in an application server, you absolutely want to know exactly where it failed. Some third-party server returned a funny response once in a blue moon, and you absolutely want to know what happened. So yeah, it's fun to make different trade-offs from Serde. I still think most people should be using Serde, but I'm excited that we get to experiment with other parts of the design space.
Hell yeah.
Of course, now I want to trash everything and replace it with bytecode. No thanks to you, James.
You're welcome. This episode is sponsored by CodeCrafters. CodeCrafters is a service for learning programming skills by doing. CodeCrafters offers a curated list of exercises for learning programming languages like Rust or learning skills like building an interpreter. Instead of just following a tutorial, you can instead clone a repo that contains all of the boilerplate already and make progress by running tests and pushing commits that are checked by the server, allowing you to move on to the next step. If you enjoy learning by doing, sign up today using the link at sdr-podcast.com/codecrafters or use the link in the show notes to start your free trial. If you decide to upgrade, you'll get a discount and a portion of the sale will support this podcast. That's sdr-podcast.com/codecrafters.